Circles. Tangents and normals to circles. It's worth at this point just drawing a quick sketch showing you that the tangent is the line that touches the circle and the normal is the line that's perpendicular to that tangent. The normal of a circle always goes through the centre. We'll have a look at an example. Show that the point 1, 5 lies on the circle x squared plus y squared minus 6x minus 4y equals 0. Any show that is going to be straightforward. All we're going to do is we're going to sub in 1 for the x, we're going to sub in 5 for the y. 1 squared plus 5 squared minus 6 times 1 minus 4 times 5 equals 0. 1 plus 25 minus 6 minus 20 is 0. Well, that's true. Find the equation of the tangent at that point. What we need to do this is we need to locate the centre. And we can locate the centre just by putting it in its standard circle form. We'll do that by doing x minus 3 all squared minus 9 plus y minus 2 all squared minus 4 equals 0. Shifting the constants to the other side you get 13, but more importantly we can read the centre is 3, 2. So we've got the centre as 3, 2, little sketch here. We've got our coordinate as 1, 5. We can't work out the tangent straight away. So what we're going to do is we're going to work out the gradient of the normal. So the gradient of the normal, just changing y over changing x, 2 minus 5 over 3 minus 1, minus 3 over 2. That tells us that the gradient of the tangent is perpendicular to this. So that's the negative reciprocal, so it's 2/3. Now I've got the gradient of the tangent, and I've got a point on the line, I can write down the equation of the tangent. Y minus y1 equals mx minus x1, y minus 5 equals 2/3 x minus 1. Don't like that fraction, so I'm going to times through by the 3. I get 3y minus 15. I'm also going to multiply through by the 2, so I get 2x minus 2. I'm going to tidy this up a little. 3y equals 2x plus 13. Everything's positive, we're all happy. Another example, a tangent is drawn from 8, 2 to touch the circle x squared plus y squared minus 4x minus 8y minus 5 equals 0. Find the length of the tangent. Important thing to note in here, a tangent is drawn from that point to touch the circle. So it is of a finite length. It is a length that we can work out. What we need to do, standard thing, work out the circle into its standard form. X minus 2 all squared minus 4 plus y minus 4 all squared minus 16 minus 5 is 0. Tidy that up. X minus 2 all squared plus y minus 4 all squared is 25. That tells us that the circle has a centre 2, 4 and a radius 5. Quick sketch of this. Circle centre 2, 4, drawn from the point 8, 2, so we'll put that point in as well. Tangent. There is 2 tangents to this circle, but they're exactly the same length, so it doesn't really matter which one we work with. What we know is that the tangent touches the circle, and from the point where it touches to the centre, they're perpendicular, because the tangent and the normal of the circle are perpendicular. We know the radius of the circle is 5. We can draw that dotted line in there. We can actually work out the length of that blue line. Length of the blue line is going to be the change in the x, 6 squared, plus the change in the y, 2 squared, add them together, square root. That tells me the length of the blue line is root 40. Now, it's just another Pythagoras question. I've got the hypotenuse as root 40. I've got one of the sides as 5. Find the length of the other side. So, a squared plus b squared equals c squared. Root 40 squared, 40, plus 5 squared, 25, plus the missing side, a squared. Rearrange it, 40 take away 25, 15, and then square root it. A is root 15. Another example about tangents, show that y equals 7x plus 10 is tangent to x squared plus y squared equals 2. X squared plus y squared equals 2, circle centre origin, radius root 2. Y equals 7x plus 10, nice straight line. If they're going to be tangent, that means that they share the same x and y values at the same time, simultaneously, which means we're going to have to do a simultaneous equation. Now the good thing about it being tangent is that there should only be one solution to that simultaneous equation. It should be the same solution twice. So I can do x squared plus the y squared, which we'll replace with 7x plus 10 all squared, equals 2. Expand that out, x squared plus 49x squared plus 140x plus 100 equals 2. 50x squared plus 140x plus 98 is 0. If it's tangent, like I said, it has to have one solution repeated. So I can do that using the discriminant. The discriminant of that, b squared minus 4ac, has to equal 0 for it to have one solution repeated. In this case, that's 140 squared minus 4 lots of 50 times 98. Quick check with that. 14 squared, 196. 140 squared, 19600. Minus 4 times 50, 200 times 98, 19600. Equals 0. Therefore, it is tangent. Thank you.